So here I will be finding the Maclaurin series and radius of convergence for the function f of x equals 10 to the x power. Starting off with this, we want to try and figure out as n equals, at least like through the first four terms, what the function would be for it, for each. Starting with that, it's obviously the base, 10 to the x. Then we want to figure out where it would be at the origin. Because it's a Maclaurin series, it's just starting at 0. So 10 to the 0 power equals 1. Then, after that, we want to figure out what the c naught will be. And that would equal 1 over the 0 factorial, which just equals 1. Then we need to go on to n equals 1, f prime of x equals 10 to the x ln of 10, because of the base of this being 10. Then f prime of 0 would equal 10 to the 0 ln 10, which equals just ln 10. Then c of 1 would equal ln of 10 over 1 factorial ln 10. Going on to second one, this time it's going to be, we're going to have ln of 10 squared. And for the double prime, and same little thing here. C2 would then equal ln 10 squared over 2 factorial, which still only equals 2. So that equals ln 10 squared over 2. So for the last one we'll do n equals 3, f triple prime 10 to the x, ln of 10 to the third power, f triple prime of 0 equals 10 to the 0 ln 10 cubed, obviously just equals ln of 10 cubed again, c3 ln 10 cubed over 3 factorial. And that's just ln of 10 cubed over 6. Now, through going through all this, we can start to see a pattern between each one of these. And what we can do is just write that we're doing these all to the nth power. So f to the n of x would equal 10 to the x of ln 10 to the nth power, because it's changes based off the n. That's how the pattern is. So f to the n 0 would just equal ln 10 to the nth power in a similar way. And c of n would equal ln of 10 to the nth over n factorial. Now, going through this, we can figure out what our series would be. And So series is n equals 0 to infinity. We'll have ln of 10 to the nth power over n factorial multiplied by x to the nth power. Now, since we need to figure out the radius of convergence, we need to, we can't really do geometric test for this because of the factorial, and so best test really is the ratio test. So the ratio test is the limit as n goes to infinity of the absolute value of an plus 1 over a of n. So this equals limit as n approaches infinity, absolute value of ln 10 to the n plus 1 multiplied by x to the n plus 1 all over n plus 1 factorial. And then we're going to multiply by the inverse of this just to make it look nicer for us. So it will be n factorial over ln 10 to the nth and x to the nth. Finish the absolute value. Now from here to help see where we can cancel things, I'll be separating these n plus 1 factors. And x to the n over n plus 1 n factorial multiplied just by the same exact thing because we didn't touch this. And so here, before we start that, actually, we can cancel the things. So we can cancel that with this, x to the n with this, and the n factorial with this. So that leaves us with an x, ln 10, and n plus 1. So the ln 10, that's obviously going to be positive, so the absolute value won't need to stay with that. And the n plus 1, that will also be positive because of the bounds of this starting at 0. So the only thing that will remain needing the absolute value is the x. So this is what we would get. And evaluating this limit, the only thing that will be affected is the denominator. So ln of 10, absolute value of x over infinity is what this would be. And that would equal 0. And at the end of the ratio test, you always compare what you get to 1, and that is what would give us our radius. And we figure out that the radius would actually be infinity because the x does not relate to the radius. So it's infinite, and so you could say the interval of convergence would just be negative infinity to infinity, and that would be everything.